We don't know yet.
Okay. Or is he online?
Hi, Dave. Would you prefer to be with the camera pointing at us here at the audience? You have a choice.
That's you guys. You all are fine.
Okay, thank you.
If something's going wrong, you'll start screaming, I hope. Okay, so my question is, do I have a third panelist? Martin Barlow, are you online or not participating?
Hello, Dave. This is Ian. I don't think we have a third panelist here for you yet, but we do have two here to start.
Okay, I guess I'll get started then. How's the room look? Are we partially full? Okay. All righty. Well, first I'll start by apologizing. That would be the Japanese style of speaking. I'm supposed to be out there. Unfortunately, I had a family medical emergency, which kept me here. And to the credit, oh yeah, hello everybody. To the credit of NPS, they were able to arrange for this hybrid session. So I wish I were there. I wish I were there more than probably than you are. Happy to be there. So we'll get started here in a couple of minutes. I think I only have two of my three panelists, so this might go shorter than planned. I have some opening comments, and then I'll turn it over to each of our two participants. For the panelists, please introduce yourself. Whatever facts you want us to know, please include them. And if you could toss in a fun fact about yourself, that would be wonderful. You know, the time you throw up on your second grade teacher, or the time you save the world when you stop somebody from pushing the big red button. So whatever strikes your fancy. So first, talk about this logistics supply chain panel. As everybody knows, logistics is the key to any military victory. That's pretty well drummed into the literature. And I think the United States thought we had pretty much resolved that problem through World War I, World War II, Korea, Vietnam, and the global war of terror. We proved ourselves to be quite good at logistics at a distance, 10, 15,000 miles far side of the world. We did great. And we got better at it. Started with Iron Mountains and then moved on to more sophisticated, not quite just in time, but pretty close to just in time military logistics. So we were cooking with gas and feeling pretty good about ourselves. And then COVID hit and the Ukraine war hit. And suddenly it turned out all that stuff we thought we knew wasn't quite as good as we thought it was. My lesson from that is that a first world country engaged in a war with a third world country is one kind of logistics, but first world countries fighting each other is a different kind of logistics. And what we're experiencing now is more of a first world on first world kind of logistics problem, which is a different problem. And it turns out a lot harder. We'll talk about that here in this panel. I do want to talk about my own recent logistics experience. Was a picture behind me, so this way. That is a U.S. Navy medium uncrewed surface vessel, the Seahawk, which Leidos built, my company, long before I showed up, so I won't take any credit for that. But we were careful to design it and build it to commercial standards. So when that ship was in that port, Sydney Harbor, it had a casualty at sea on the way into the port, which damaged the propeller and we thought had bent the one of the propulsion shafts. Had that been a purely military ship, that would have been a real problem. Getting a military dry dock, military parts, all of that stuff. Since it was fully commercial, it went into a commercial dry dock that was used to dock in fishing boats and tugboats. Popped it right in. Didn't take but a couple of days to find an available dock. Pulled the shaft, pulled the propeller. The propeller was fixed. The shaft turned out to be not bent, but the shipyard, the commercial shipyard, was quite capable of fabricating a new one if it needed to be, since it was all commercial parts. And it was in and out of the water in less than 2 weeks, fully functional. The only concession to being a military product was the commercial dry dock had to be towed into an Australian naval base for security reasons. So absent that, we'd have probably done it in a week. So in that case, design and engineering resolved a logistics problem that happened 9 years after the ship was built. So logistics isn't always just getting the part to where it's needed. A lot of logistics is making sure you design it so that you don't need a special part, or if you do, it's readily available. So with that little short story, I'll turn it over to our first speaker, Rebecca Wostenberry. How did I do? Is that good? Is that close?
Close. It's Wostenberg.
Wostenberg. Okay. And she's from NDIA Emerging Technology Group. And if you could introduce yourself, and you have about 20 minutes. And if you want to take longer, we're all good with that. Over.
All right. Well, thanks so much, Dave. Good afternoon, everyone. As Dave mentioned, my name is Rebecca Wostenberg. I am the Senior Director for Research at NDIA's Emerging Technologies Institute. In my capacity, I oversee all of our research activities across the board, but I also serve as the chair of our Emerging Technologies Supply Chain Study, which I'll be talking more about today. And I was the lead author for the Hypersonics report, which we're going to be discussing. I also have one of my co-authors in the audience, Wilson Miles, and then an additional co-author that wasn't able to be here today, but I just want to thank them for all of their efforts as well. A little bit about my background. So I've been with ETI for the past 3 years since we were stood up in 2021. And I'll talk a little bit about sort of who we are and what we're doing. Prior to that, spent some time in the Pentagon in a few different roles, most recently as the Deputy Director of the Secretary's Action Group. So directly supporting 2 different Secretaries of Defense on long-term strategic planning, NDS implementation and the like. And per Dave's request, a fun fact, it's less of a fun fact, more a caveat, I'm 6 months pregnant. So if I have to stop and catch my breath, bear with me because baby's pushing up on my lungs right now. So I apologize in advance if I pause every so often. So before I dive into the report, I want to share just a little bit about the Emerging Technologies Institute. I think most people here in the audience are probably familiar with the National Defense Industrial Association, NDIA, that we're an affiliate organization of. But just in case you're not, NDIA is the oldest and largest defense industrial association in the country. But we're a 501c3 educational nonprofit. So really we're focused on kind of being that convener to bring together the key stakeholders across industry, government, and academia to really try and get after some of the biggest issues that face our warfighters. NDIA is a member organization. We have over 60,000 individual members, over 1,500 corporate members, and they include small, medium, and large companies all across the board, primarily small companies, but we have all of them. ETI is an affiliate, like I said, of NDIA. So essentially we were stood up with a recognition of kind of NDIA needing to play more of a role in the conversations around emerging technologies. And I'll say from the beginning, in case it's not clear, when we say emerging technologies, essentially we're talking about those lists from the 2018 National Defense Strategy and 2022 National Defense Strategy of what the critical technologies to DoD are. ETI performs research, we host events, bolster public awareness, really through educational products, reports, and the like. Can I have the clicker? Thank you. So with that, I'd like to dive into our hypersonics report. It's called Hypersonic Supply Chains, Securing the Path to the Future. So really, the goal of the report, or the goal of the whole study, was to assess the current state of hypersonic supply chains and then provide actionable policy recommendations for their development, health, and resilience. So a little bit of background on the project. In 2021, when we were being stood up, obviously we're kind of still in the midst of COVID, coming out of COVID, and supply chains were at the forefront of everyone's mind, inside government, outside government, et cetera. And as we looked across the landscape, we saw that there was a lot of efforts in a lot of different sectors, a lot on defense supply chains, but there weren't as many efforts specific to defense emerging technology supply chains taking place outside of government. And so that was really the niche that we were looking to fill. Hypersonics was the first report in this series. We published it last year. The full report is available online at our website there on the bottom of the slide, emergingtechnologiesinstitute.org, and you can go to our reports section. We also just published the second report, which focused on directed energy weapons supply chains. So if you're interested in that, would also recommend that you check it out. And we're in the process of standing up the third iteration that's going to focus on quantum computing supply chains. So really, this is a multi-year effort to look at multiple different technologies in the supply chains that support them. And what we're trying to do here is really kind of put yourself 5, 10, 15, however many years in the future and say DoD has followed through and is actually fielding these weapons at scale. And so what are the supply chains that you need in place to then support those in the future? And what are the steps you need to be taking today in order to do that? So with that, before I dive into kind of the key findings and recommendations from the report itself, I want to discuss our methodology a little bit. So ETI kind of sits in a unique position at NTIA. There's obviously hundreds of think tanks around DC. But what kind of makes us different is honestly our position as part of NDIA and our access to our members, many of whom may even be in the audience today. There's a ton of expertise that sits there. These are companies and individuals that live these supply chain issues day in and day out. And so we really wanted to set up our methodology to leverage this expertise. So the first step we took was to establish a partnership with one of our university members of NDIA. That's the University of Maryland, and specifically their Supply Chain Management Center. There we worked with a team of professors and graduate students, and they kind of laid the foundation for our research. I will say all of this was done at the unclassified, publicly releasable level. Obviously, we recognize that has certain limitations. There's certain things we weren't able to get into. But we determined early on in the project that we wanted it to be available to a wider audience, especially non-traditionals, et cetera, that might not necessarily have security clearances. So the University of Maryland team really kind of laid the foundation for our research. So identifying kind of single sole source supplier issues, kind of tracking these supply chains as best you can, obviously, given how opaque they are. Next, we then conducted a series of working groups where we brought together the key stakeholders from industry, government, and academia to really dive deep into 4 specific aspects of the supply chain. And those 4 specific areas are, first, critical raw materials and goods. Second, manufacturing base and workforce. And we also included testing infrastructure in there that I'll talk about in a minute. The third area was supply chain security and vulnerabilities. And fourth is international partnerships and allied nearshoring. Obviously, there's a lot of different ways you can slice and dice supply chains, but those were the specific areas that we decided to focus on. And so each of those working groups really dive deep into those specific areas. From there, we took kind of the key insights from the working groups, the work that University of Maryland had put together, as well as internal research, and poured that into a draft report. Prior to publication, we submitted the report to what we call our peer review committee, as well as a group of external reviewers. The external reviewers are really technical experts that can ensure the technical accuracy of the report. And then the peer review committee it's primarily made up of distinguished former senior government and industry officials, people like the Honorable Ellen Lord, former Congressman Mac Thornberry, et cetera, that can really especially look at the policy recommendations that we're making and provide feedback on those. So all of that feedback was incorporated, and then we published the report, like I said, last year. So with that out of the way, I'd like to kind of dive into the actual report. It's a lengthy report, it's over 50 pages, so I'm just going to be hitting wave tops today, but happy to dive deeper into any areas during the Q&A if we have time. So overall, we assess that the current hypersonic supply chains, including manufacturing base, supply of critical materials, testing infrastructure, and workforce, are insufficient to affordably field hypersonic weapons at scale. So the question is why? Why is this? And unfortunately, the primary reason for this assessment is the lack of consistent government demand signal over the years for hypersonics. I think this is a theme that we heard a couple times this morning, and I'm sure we'll hear it kind of going forward. Over the years, if you look at the history of hypersonics, DoD has really wavered in its commitment. You have some years where funding is high and some years where it's low, some years it's a priority, some years it's not. And so because of that, you end up with a small manufacturing base with limited suppliers that's really suited only for manufacturing limited numbers of hypersonic systems with long lead times. Essentially, from the industry perspective, what we heard a lot in our working groups is that companies, they need to know they're going to have a return on investment, to be quite frank. Industry, we heard, was eager to invest in this technology, but the business case needs to exist for companies to invest in the necessary infrastructure and personnel. As I mentioned before, our report really focuses on sort of 4 key areas of the supply chains. The first is critical raw materials and goods. Obviously, hypersonic weapons requires substantial quantities of critical raw materials and goods. It would be impossible to pull every single little component, but in the report, we tried to give kind of a sampling across the board of some key ones. And here I'll just touch on a couple. The first we focused on was high temperature materials, which are crucial for hypersonic systems, including applications like heat shields, thermal protection systems, and the like. Within high temperature materials, a number of different materials and metals are needed, but one of the most important for coatings for higher speed hypersonic systems is carbon-carbon. However, according to what we heard from our working groups and our research, there are only 3 suppliers for the carbon-carbon composites used in hypersonics vehicle coatings. Obviously, when you're only dealing with small numbers, that might not necessarily be an issue, but as you're scaling up, this is an area where the government's really going to run into an issue of, do they have enough suppliers? Can they meet the demand? Another vulnerability that I think is probably well known to this audience is rare earth elements. Obviously, that's used in many different systems far beyond hypersonics. But really here, the story is Chinese dominance in both mining and processing introduces significant risk into the hypersonic supply chains. We've seen some recent developments of the government trying to work on this and trying to stand up domestic production, processing, et cetera. But there's a lot more work that needs to be done. One material that's actually seen some positive movement in recent years is ammonium perchlorate, or AP, which is a principal raw material used in solid rocket propellants. Until recently, American Pacific was the only DoD-approved domestic supplier of AP. However, in recent years, Northrop Grumman stood up AP production, bringing the number of suppliers to 2. Well, only time is going to tell if 2 is sufficient. A second entrant into the market does reduce some of the risks associated with only 1 supplier and has the potential to reduce costs due to competition. So moving up the supply chain to manufacturing base, testing, and workforce, we found that all were insufficient to support fielding hypersonics at scale and faced many different issues. Overall, like I said, the hypersonics manufacturing base faces limited suppliers across the board in areas like rocket motors, hypersonic structural components, and protective items like the thermal blankets that shield the vehicle from excessive heat. At the same time, due to the lack of demand signal for large quantities of hypersonic weapons and a low supply of components, lead times have grown exponentially. Again, in the short term, if you're only dealing with sort of onesie-twosies, a long lead time might not be an issue, but in a real wartime scenario, this is obviously going to be a significant problem that needs to be addressed. Now, although testing infrastructure is not traditionally considered as a component of supply chains, it plays a crucial role in really moving the hypersonic systems from the early developmental phase to a fully fielded system, and therefore we deemed it within the purview of our study. I will say it's a subject that deserves its own study and has been studied over the years, but also I'll just touch on a few key issues that we looked at in our report. First, hypersonic systems must compete for test time slots with current high priority programs such as missile defense and nuclear deterrence. The age of existing testing infrastructure is also a significant issue where most testing facilities were built decades ago and really lack modernized data acquisition tools. Our report goes into a lot more detail on testing infrastructure, but suffice to say for this conversation that the overall testing infrastructure is insufficient and needs to be addressed. When it comes to the hypersonics workforce, there's several different issues that we discuss in the report. First, the hypersonics workforce as a subset of the aerospace industry faces similar challenges to those of the whole industry and others in the post-COVID era. Industry has seen rising employee turnover, shortage of talent, et cetera. And according to what we are hearing in our working groups, the current hypersonic specific talent is also unbalanced and misaligned to current needs. We found that there's a plethora of early and mid-career aerothermal expertise, but a dearth of expertise in other needed areas such as hypersonic controls, system design, and high temperature materials. The next aspect of the hypersonic supply chains that we looked at was supply chain security and vulnerabilities. Overall, these supply chains, like other emerging technologies, face a range of threats related to cybersecurity, counterintelligence, and intellectual property theft. I unfortunately won't have time to dive deep into each one today, but again, would encourage you to take a look at the report. And I'll just highlight kind of overall, we found that the cybersecurity challenges are found at all levels of the supply chain, from kind of your critical raw materials, mining, processing, et cetera, all the way up through. Also, interestingly, additional recent reports have indicated that China has recruited several former scientists from Los Alamos National Lab to work on their hypersonics programs. We talk a lot about the transfer of expertise to China, especially when it comes to hypersonics. It also reaches even down to the semiconductor level, where we talk about some specific examples in the report. And so the final aspect that we looked at was international partnerships and allied nearshoring. Here, the US has a strong multilateral partnership via AUKUS and also bilaterally with Australia, Norway, and a few other countries. Obviously, given the type of technology and the sensitivity, partnerships are a little bit limited on this, but that's to be expected. However, we do assess overall that these partnerships need to be strengthened to better secure hypersonic supply chains. And when I talk about the recommendations, I'll get into a few of the specific ones. And with that, I will move on to our recommendations. The report contains numerous different recommendations, so I'm just going to hit some of the top ones here. And we group them all by those four specific areas. So if there's one in particular that you're most interested in, you can kind of scroll to that part of the report and read it. Overall, the single most important step that the US Department of Defense can take to strengthen hypersonic supply chains is to provide that clear, consistent demand signal to industry. But this is just the first step. There's specific areas that need further investment, especially in high temperature materials such as carbon-carbon. But then the investment also needs to go beyond government. And we recommend in the report that DoD should encourage venture capital to invest in areas where there's overlap between the hypersonic supply chains and the growth of the space industry. On the workforce side, we recommend that there more work be done via the UCA, the University Consortium on Applied Hypersonics. Here, especially, the focus needs to be on educating that mid-level talent. Like I said before, we found that there's more on kind of the early level or early career side and a fair amount on the senior level, but there's this dearth kind of in that mid-career talent, so more work needs to be done there. We also recommend that DoD needs to increase the tempo of flight tests. More tests need to be occurring regularly if we're actually going to be fielding these at scale. On the workforce side, again, more work needs to be done overall. There really needs to be kind of a holistic report that looks at the hypersonics workforce that then has the results shared with industry to help identify and address concrete shortfalls in order to scale up hypersonic production. Obviously, our report tries to kind of get at the first step in that, but there's much more work that needs to be done. Defense industry should also be looking to make sure it has both the traditional and additive manufacturing capabilities needed to produce hypersonics at scale. We have a whole section in chapter 2 that looks at additive and advanced manufacturing and sort of the areas where more work could take place to bring down some of the costs associated with hypersonics. OUSD A&S, acquisition and sustainment, also needs to ensure that the acquisition workforce is adequately prepared for this procurement at scale. There's an education piece here that needs to occur. And then finally, on the international piece, we recommended that the US government needs to be looking and to expand partnerships with Canada and Australia, kind of in two different ways. First, to diversify raw material supply and expand testing partnerships. Again, especially on the raw material side, this is where we've seen a little bit of activity in recent years that looks promising, but there's still a lot of work that needs to be done. So overall, our report lays out a number of challenges that these supply chains face, but we also try and provide recommendations on what can be done about it. But action needs to be taken today because each of these issues are going to take time to address. but each one are also critical for securing the path to the future. Thank you for your time today, and I look forward to your questions.
That was excellent. Thank you very much. That was a topic I don't know much about, and I will look up your report and read it. So it's appreciate your time. That was some excellent work. Next, I'd like to introduce Dr. Geraldo Ferrer from the Naval Postgraduate School, our leading light in logistics and logistics management. So over to you, sir.
Thank you very much, Dave. Thank you for being here. Good afternoon. My name is Geraldo Ferrer. I'm professor of supply chain management at NPS. And this study follows a number of previous studies with students from NPS, at least a dozen of them. More recently with faculty associate Aaron Heinrich, Major Gabriel Bailey from the Marine Corps, Lieutenant Commander Elizabeth Courtney, and Lieutenant Commander Pablo Rodriguez. And by the way, if anyone here has research topics in logistics that our students could work on as their thesis, that would be really encouraged and we would appreciate. So I, just a second, and here it is. So I'd like to explain that date, January 2024. There was an early version of this brief that I gave to UpNav 4. And that date was quite opportune because just 5 days earlier, there was this headline from Reuters saying, House Committee raised doubts about U.S. Navy's Indo-Pacific logistics, doubts about a plan to move fuel from Hawaii to storage facilities across Indo-Pacific, and warning the U.S. military risks being unprepared for a possible conflict. And our study was precisely about that, how to support expeditionary forces in the Indo-Pacific area. And I'm gonna, this is more or less the agenda. I'm gonna describe a scenario, a notional scenario that we came up, the assets that we propose using, mostly from Navy, next generation logistics ships. A proposal to use JP5 as the single fuel in naval operations. And I'm gonna justify that. The resupply options that we use in that scenario, and the network design and the results. So this scenario here is more or less the one, not the scenario itself, but the fact of being prepared by 2045. That is a request by the Commandant of the Marine Corps, using expeditionary advanced-based operations. So scenario being adversaries in the Indo-Pacific AOR have challenged the U.S. ability to maintain sea control and air superiority. Basically, that's the idea. The region Indo-Pacific, and the scenario, if you look on the map, here we have, that's totally notional on class. The dashed red lines, the weapons engagement zone limit. You have outside the WES, you have three console stations, east, south, and west. The expeditionary advanced base operation is centered in Brunei as the location of the company, with as the hub to 4 platoons, 2 in the Philippines, 1 south in Indonesia, and 1 in Malaysia. So the focus here, how is it that we could supply this EABO with fuel? Focus is exclusively on fuel here. So this is, we simulated several combinations of this scenario from these consoles outside the WES, assuming that at those console points, fuel arrived there somehow. Now, how are we going to take fuel from there to the EABO with a hub in Brunei and these 4 platoon areas? So on the left, you see the focus would be shipping by sea, as a small tanker would take the fuel from the consoles to the hub, and from there, a different kind of ship would ship that to the platoons. You also see air delivery, which is unusual, but we're going to justify in a moment. On the right, you see how that fuel would arrive at the platoons, mostly by sea from the company, but also possibly by air from the console points. This is the main ship that is being considered as next generation logistics ship, the platform supply vessels, 15 knots, 3,500 nautical miles range. So far, very standard. 1.5 million gallons. So this is a mini tanker, much smaller than a typical oil tanker. That would be the main source of transportation from the console areas to the company. And from the company to the platoons, this is the notional landing, medium landing ship that the Navy is considering. 14 knots, 3,500 nautical miles. The capacity here being 90,000 gallons. So you see much smaller than 1.5 million gallons on this one. So this is information was given to us. It's the assets that we use in the study. The third one, I mentioned air delivery. So there are a number of seaplanes that have been discussed. One of them is this DARPA concept, the Liberty Lifter. We like this specification, 150 knots. It's a good speed, much more than the ship, 10 times as much as a typical ship. Now, the more interesting feature there in a smaller font on the left, you see that in the cargo area would fit 26 fuel tanks, 900 gallons each. And that would be the way they would ship fuel on this aircraft. Strange, unusual, but why would we pick a ship for that? Let's save that for a minute. The other unusual, I mean, not so unusual, many of you have heard that idea of single fuel. We've been studying that for several years. The technological aspect has been studied at length by NAVSEA and NAVAIR and shows that using JP5 to fuel the battleships wouldn't cause a problem and reduction of life of the power plants. First, let me introduce. So F-76 on the left is a type of diesel fuel. It's a military grade fuel used by the battleships. On the right, JP5 is a type of kerosene, not terribly different from jet air used by commercial aircraft. The main difference there is that the flash point is higher than 140 degrees Fahrenheit. That is quite important because that makes it safe to operate on a ship. So it's the only type of air fuel that can be used at sea. So you see the same flash point as the diesel used to power the power plants. Now, JP5 has some inconvenience, let's say, limited availability at the moment. And of the physical characteristics, the most relevant, I'd say, is the last one on the table, the fact that it has a little less energy per gallon than F-76, but at 2.5% is something that we thought could be manageable. So we included that in our simulations. Difference in specific gravity has been raised in the past, but at 3%, it couldn't possibly affect maneuverability of safety of the ships. So anyway, the main, there are other challenges, but I'm going to focus on the fact that the logistics benefit that has not been studied by others to my knowledge, but we had a few studies, like the thesis from 2020 by Lieutenant Commanders Jimenez, Walters, and Lessner. So they look at this scenario, shipping from Hawaii to an irregular tanker to this example console point. So the red, no, not red, the yellow line, let's see if I can point it here. That one is how far a tanker would go. And the red circles are pretty obvious, the reach of the DF-21. So if with that sample console point, from there, a traditional, a typical TAO with a single fuel, because it's using single fuel, because it does not have to have separate storage for F-76 and JP-5, it's equivalent to expanding fuel capacity by anywhere from 10 to 20%, depending on the way that the type of ship that is transporting, the type of tanker that is transporting it. That is because of the pooling effect, the fact that sometimes if you have a dual fuel, you may need to refuel just because you ran out of one of the two, or you're about to run out of one of the two. So the simulation shows that the benefit would go from somewhere to between 10 and 20% of extended reach. That alone was a very interesting result of the logistic benefit of single fuel. This other study by Lieutenant Commander Witt, an OR student that graduated in 2022, she looked into transport from Greece to Scotland. What would be the difference between a dual fuel and a single fuel? And there we actually did a complete analysis. Let's do that transportation with by carrier striker groups, amphibia readiness group, doing a number of exercises that would be typical to do in that trajectory, flight operations, pre-assault, assault, sustain. With a dual fuel, you would spend 94 hours on refueling operations compared to 89 on a single fuel. With a dual fuel, you would have 5 replenishments at sea as opposed to 4 with a single fuel. And the amount of fuel consumed would also be lower with a single fuel. So these are just 2 of the logistics examples that we worked that show the single fuel provides a substantial logistics benefit. There are other issues. We also looked at cost of actually retrofitting existing ships from dual to single fuel and et cetera. But that's for another conversation. So we use only single fuel as the fueling approach for the example that I showed you in the very beginning. So to supply the expeditionary advanced base in that location that I described, we looked into these network, this mixed network. One of them would be only using that mini tanker, the PSV, from the consoles to the company, and from the company to the platoons, we would use the LSM, or direct shipment by air from the East Console to the platoons. So those that demand levels here in the lower table, they were provided by the Marine Corps. Those sustain and surge demand. Those notional storage capacity, we thought they were reasonable and we verified with them. They gave the go-ahead. On the top, you have the capabilities of the 3 modes of transportation. So this is the network of a distribution using the shortest path in each case, a mix of shortest and safest. So these are the results. So let me explain this chart a little bit. There's a lot of information, each one of them. On the vertical axis that you see percentage going from 0% to 60%, that is the number of times that we had a shipment arriving later than desired. So late shipments, late deliveries. So in the first chart, you have using a single tanker. So here in this picture, so that's the tanker here. If you only have one of these guys and 2 of these and none of these, you would have, as shown here, more than 50% of the deliveries would be late. Okay. Now, this line, the gray one, the higher one, means I don't have any of the seaplanes. The middle line, the red, just by adding 1 seaplane, that late delivery drops from 50 to 30%. If you add a second seaplane, you're well under 10% late delivery. So even though the seaplane has very low capability, it's just enough to make those deliveries closer to on time, almost 100% of the time. Then you say, okay, Gerald, but I could increase the number of tankers. Well, actually, the difference is not that great. If you still 0 seaplane, 2 PSVs, and 2 LSM, you're still at almost 50% late deliveries. So in this scenario, with 2 of the PSVs, you would need 4 LSM to be able to make 0 late deliveries without a seaplane. So one more piece of information that we shouldn't forget. This was done with single fuel. The performance would be, I believe, far worse if we were using dual fuel in these scenarios, in any of these scenarios. So, and that's a sustained demand. Unfortunately, the surge demand, the complexity of these scenarios, because running multiple times, etc., the lines are not as smooth as we would like, and mostly because of the mathematical complexity of the equations here and simulating them. But it's I'm fairly confident on most of it that shows that on a surge scenario, more than 60% of the time we would have late deliveries if we don't have a seaplane in there. And you add 1 of those, it drops to 40. You add 2 of those, you're still at 30% on a surge scenario. So the bottom line is that you need a combination of the Liberty Lifter, the seaplane, and a single fuel to have a decent performance here, unless you're willing to have lots of all types of assets, which probably is not something that the budget would be able to afford. So there is one more scenario here. If you have a preposition assets, meaning having those transportation assets already starting early on, it helps, but not tremendously. And with that, I'm just about over. So I'm going to leave this one. If anybody has any question, that's it. Thank you very much.
Thank you. That was awesome. That was good. Thank you very much. So we're open to questions. We're taking questions online and also from the audience. One person has already jumped in with an online question, Charles Mahan. So I'll read the question, and I think it's a question for me. So I'll answer it, and then that'll give you all out there online or in person time to come up with some other ones. These are two very meaty topics, so I'm looking forward to your questions. We will not have a third panelist, so we have plenty of time. So the question online is, are not U.S. Navy specs largely a result of lessons learned in battle, therefore distinct from commercial shipbuilding standards? And the answer, it's actually a question, by the way, it's a super question. And the answer is yes. Navy specifications for combat ships are very different in many respects than commercial standards. But that's not the whole question. That's not the whole answer to the question. So recently on my own, I've been studying organizational learning, and there is a thing called a single loop learning and double loop learning. So single loop learning is what you're describing in your question. We send a ship into combat, it gets hit, we see why it got hit, what happened, we fix the problem. We make the ship more survivable, we put more weapons on it, we make it go faster so it's harder to hit, those sorts of things. Double loop learning looks at why things happen and how can we change fundamental facts about what's going on in order to change the potential solution to the problem. And that's what Dr. Farrar talked about, which is a single loop solution to oilers or provide fuel to Marines at the knife edge of combat, if you will, would be to build tankers that are more survivable. They're bigger, they're armored, they have lots of weapons, they go really fast, and that's how you solve it. What Geraldo did in his work with his students was to implement double loop learning, which is let's change the basic assumptions we make about how fuel gets to the battle force. So, dispersing it amongst many platforms, choosing different modes of delivery, surface and air, using console points and intermediate depots. So, I don't remember how many oilers the Navy has. I think it's not very many, maybe a dozen, maybe a few more. And that's not very many targets. What Geraldo talked about now introduces, frankly, dozens of targets potentially, and disperses them across quite a wide geographic area, which is archipelagic. I think that's the right word, which means they're hard to find because they're in with islands and everything else. So the approach there is to change the fundamentals of the problem, which then introduces new and innovative potential solutions that depart from the standard, make it more survivable, make it more defendable, that sort of stuff. I think your question was inspired by the picture behind me, and that's very much the same thing. You have a $1.7 billion destroyer with all the weapons on it. Normal way of doing things. It's very survivable. It has lots of weapons, very, very effective self-defense, as we're seeing in the Red Sea today. Or do you take several dozen platforms that cost in the double-digit millions and spread them out? They're not survivable individually, but there's a sure lot of them. And they have a number of weapons, or could. These don't, but they could. And again, that fundamentally changes the nature of combat, which then drives to a fundamental different approach to the design of the combat unit. Hypersonics is the same kind of thing. We're pretty good at shooting down missiles that are going Mach 2 or Mach 1, fly at 40,000 feet, 30,000 feet, 50,000 feet. We got that problem's fixed. Not so much something flying at Mach, what is hypersonic, Mach 7, Mach 8, cooking with gas. That's a hard problem. And especially if it maneuvers, which maybe they do, maybe they don't, I don't know. So again, that's double loop learning, much more effective at solving problems. So long answer to an excellent question. Thank you for asking that. Let me go to the audience and see if there are questions in the audience. I have an online question if there aren't, but over to the audience if there's a live question. And state your name and who you would like to answer the question.
So, Lieutenant Dorch, finance major, NPS student. And this is just in the conversation of fuel types. I was wondering in general, do we have enough JP Vive readily available in order to satisfy the F-76 needs? Or is this all kind of a little bit more hypothetical?
No. The simple answer is no, but there is not right now because there is no demand. You're not going to have refineries making, producing a fuel that the demand is limited. I know a thing or two about petroleum. I worked 9 years in the field in the petroleum industry and understand a little bit of refining. And I can tell you that the supply will follow demand for this type of fuel. JP5, yes, it is a specialty fuel. It's not changing the refining process. There are additives, but it wouldn't be a challenge to increase in, see, just like the refineries will have to adapt and that will take time, and believe me, not a lot of time. It will take more time for us to modify our ships to make sure that there's not a drop of F-76 in ships, because it's very important. The risk of contamination and eventually having F-76 mixed in a JP5 that will go in an aircraft, that's the last thing we want. So we need to make sure that the ship goes all at once from a dual fuel to single fuel and absolutely zero violation. That process is going to take time and longer than it would take for refineries to adapt. Definitely longer. So that aspect wouldn't worry me. Yeah.
Okay.
There's a hand over there.
I do hear the microphone. Hi, Maciej Macanowicz, NATO Diana. I do have a question to Rebecca. You mentioned international partnerships, naming Canada and naming Australia. Have you considered or would you be interested in looking at other forms of partnerships? I mean, NATO initiatives. The reason why I am asking that question is that our agency is currently leading an initiative to pull demand from all 32 nations and use this as the economic incentive for venture capitals.
Thank you for the question. I would say we also, in the report, I wasn't able to talk too much about it, just given time constraints, but we also talk about the partnership with Norway that's also in place when it comes to testing. I think, personally, just my personal opinion, I think it'd be great for NATO to work in this area. I think that they're, especially on the supply chain side, we need to be looking to our international partners and allies of ways to, like I said, ally nearshore. Are there capabilities that these countries have? Do they have some kind of very niche specialty where they can come in and they could help with high temperature materials, or name your component? I specifically mentioned Canada and Australia because they're kind of known entities. Obviously you have AUKUS, but I think that there's a lot more work. And frankly, I think somebody needs to be looking at this issue of how do we leverage NATO overall to diversify our supply chains. But I think hypersonics could be a great example, but I think overall it also needs to be addressed. So hopefully that answers your question.
Sir,
Okay, other questions?
Ed
Go ahead.
Rabano from Global Identity. Question I have is, in support of the surge capabilities we have utilizing the infrastructure, transportation infrastructure, what about the consideration of utilizing the regional capacities for the already developed deposits of oil, petroleum, et cetera, in that theater as another baseline? Witnessed historically World War II and the grab for the South Pacific for resources.
The study does not preclude the use of oil that is already in a theater. So we intentionally, we were focused only on taking petroleum from outside the West into the West. There are, we're involved in other studies. By we, I mean myself and other students, studies that relate to expanding prepositioning activities for the Marine Corps, specifically Marine Corps INL. And yes, this prepositioning is definitely a very important piece of that puzzle. Our concern there was for that specific scenario, because I think that scenario is useful not only to demonstrate the value of single fuel, but also demonstrate the gap that exists today on bringing fuel into the theater with the assets that are currently under consideration, the next generation logistics ships. They're interesting. It's better than our situation today, but it is still not sufficient. And when we started, we didn't think at all about the seaplane. Was when we saw that it was impossible to solve the problem with the next generation logistics ship with satisfactory performance, and we started digging around, what else can we use? Because more ships, that's going to be perhaps more expensive and less flexible. And like Admiral Lewis was saying, larger and easier targets. So, but yeah, preposition is definitely an important piece of the puzzle. Thank you for the question.
So we have a question online. I'll jump to that. Prescott Paulin. If we prove an air to fuel or water to fuel, why not put a nuclear core in one of the new Navy oilers under construction and just generate fuel at sea without the need to resupply on land? I think that's an awesome idea. We're a little nervous about proliferating nuclear power plants, but we're also pretty good at running them. So from the Navy perspective anyway. So I think that's a topic worth looking at. Geraldo, do you want to touch on that at all? Not my area of expertise.
Really, beyond that, I haven't heard of
Okay.
that idea before outside of my
All right,
expertise.
but I know from my own reading that there is a growth of smaller modular nuclear power plants, not the super mega that have been used in the past, and those are starting to be built. And I have read some literature on small nuclear power plants. So I think there's the technology is there. Putting it in an at-sea environment, as you describe, I would call intriguing, and probably needs some work. Rebecca, did you have something you want to add? Camera moved to you.
No, I think you've covered it sufficiently.
Okay.
We do have a couple of questions in the audience here as well.
Okay, good. All right. Over to the live questions. Go ahead.
Hi, this is Cynthia Cook from CSIS. I will follow that very hard question with one that I hope is a little bit easier. And that is going beyond fuels. And this is for all three, the two panelists and Admiral Lewis, with your different perspectives. Going beyond fuels, can you talk about current opportunities and challenges and other forms of logistics and supply chain issues, specifically in the Indo-Pacific? Thank you.
Okay, I mentioned a moment ago prepositioning, and the Marine Corps that I've been a lot of contact with installation logistics in the last 12 months. So I'm just repeating what they're doing. They're very concerned with building a global prepositioning network, and the study that we're doing for them is developing a metric that helps us assess, choose, select the additional sites of preposition that we should have in the area. So we've examined a few options. So in addition to what we already have, and with a focus on the Marines, so the Navy, Army already have some places that the Marines are not collaborating. So that's a focus. How to improve prepositioning, how to improve local support, meaning that not just prepositioning, not having the material there, but having the ability to service marine equipment on that area. So that's an expansion that is quite important, and it's a focus. I think that was a guidance that came from the commandant of the Marine Corps. Yeah. Thank you.
Yeah, this is Dave Lewis. I can speak for the company I work for now, Leidos. We have designed and delivered 2 autonomous low-profile vehicles. They would be classed as small USVs, uncrewed surface vehicles. They're built to be low profile, which means hard to find. They're not technically stealthy, but they have a very low visual profile and a very low radar profile. And they're designed to deliver, I don't think it's been publicly released, but a certain amount of cargo, 1,000-mile range, which means 1,000 miles out, 1,000 miles back, autonomously. And those can be built. They're very inexpensive. They're inexpensive, comparatively inexpensive. So they could be built in quantity, and they would carry a small amount of ammunition or other items of interest to a remote site. Marines would unload it and then return the vessel to its point of origin, and those would be attritable. There's 2 boats out in service now that are being tested by the Marines. It's through McWill, the Marine Corps Warfighting Lab, and Navy Surface Warfare Center. Carderock. There's been a couple of press reports, which is why I could talk about it. I also know just from the open press that the Army has activated or reactivated a logistics command in Japan, Yokohama, for regional logistics supplies, smaller craft, not big ships, not Navy ships, but Army, medium and small ships. And I know the Army has a solicitation out for a new design logistics supply ship. The name escapes me off the top of my head. And then, as Dr. Farrar mentioned, the Navy's new oiler program is, I think they've just redesignated it to a light oiler, AOL. And it's designed to be, I think, a quarter the size of a traditional Navy oiler, and bigger than what he showed, but much, much smaller than an AO or an AOE, which is the current status of oilers. So I would say there is a lot of experimental, from my experience, my recent knowledge, there is a lot of experimental work in logistics, innovation in logistics in terms of delivering things, fuel as well as other things. 3 of the Navy's medium USVs, uncrewed surface vehicles, are based on offshore support vessels for the oil industry, which are essentially cargo haulers, big aft deck, very high speed. Their competition in the oil industry is helicopters. That's fairly impressive, to run supplies out to oil rigs. And those are being repurposed or redesigned or designed from the ground, from the keel up as USVs to support the Navy or the Marine Corps or the Army. And they have substantially greater cargo capacity than the low profile vehicle I talked about, and more than the Seahawk Sea Hunter, which you see behind me there. So, and there's 2 of those in service now, Ranger and Mariner. And there's a third one, Vanguard, which is under construction down in Austell. That's an L3 Harris product. Ranger and Mariner are both Leidos products. So I'd say there are holes in the water and active experimentation on how to do that, and I would consider that a hot topic today. Realization that that's an issue in the Pacific AOR, and again, back to my double loop learning, really challenging some of the basic assumptions behind how we've done logistics for the past 60, 70, 80 years and I think in a very innovative and progressive way. So my company's actively involved in it. I know there are many other companies who are actively involved in it. And Liberty Lifter is a good example. We're involved in that at Leidos. So yes, Cynthia, that's a very hot topic. Army's active in that. Navy's active in it. I'm not familiar with what Air Force is doing. Marine Corps obviously is very active in it, given their new strategy. So does that answer your question? Over.
Yeah, I would just add, I would kind of look at it from a different perspective of kind of zooming out to the 30,000 foot level and say, hey, what lessons from history can we learn? I'm a big history buff, so I love going back and let's read what the challenges we ran into in World War II were, or Korea or Vietnam. And are we going to run into those? Obviously, technology changes. We're in a different era now, but some of these issues are age old. So go back to history, see the issues they faced, and let's figure out how we're going to address them now before the fight begins.
Can I add to
Okay.
that?
Go
Because
ahead.
one idea from World War II that some students have worked into their thesis, the idea of those, how to call the logistic ships that can actually do repairs. I forget the name right now. Who can help me?
Tenders.
Tenders, that's right. So tenders with additive manufacturing capability as well. So as additive manufacturing evolves, they would be added to the logistics ship, so that we also would be, well, less exposed to the lines of communication with CONUS that most likely would be interrupted. So that is also potential. Additive manufacturing has some very substantial challenges in a large scale. Materials, variety of designs, etc., size, but that would be one opportunity to consider in the long run. Yeah.
Okay, we have 2 questions online, both for you, Dr. Farrar. First one is from Prescott Pollen. There's a patent pending for a global logistics prepositioning network, and an Air Force CSO contract for resilient basing was issued for it. To integrates with tak.gov. Happy to sync and introduce you to the contract holder out of Honolulu. So Prescott, if you could reach out to Dr. Farrar or vice versa, I think that'd be a good connection. Second question is from Dan Moran. The question is for Geraldo. Did you do any research to determine the scope of equipment that can only run on one fuel type? If so, what general cost and schedule could be expected to be able to change, retrofit all equipment to run on either fuel type? Over.
What I call retrofit early on is mostly the completely removal of one type of fuel and put another one. There is no equipment change. And the equipment in the case would be all battleships and power plants on the floating assets. There is a student thesis from December 2023, I believe, that looked into the marine vessels and they design a schedule how long it would take to convert those ships and scheduling together with their maintenance cycle. So it would take anywhere between 5 and 8 years to do all of the LSM, LSHs. But that would be mostly cleaning tanks and fuel lines and fuel pumps. That's how it is.
Yeah.
There is a question from here.
Okay, we have time for one more question. We've got about 2 minutes left, so go
Good
ahead.
afternoon. I'm Lieutenant Ashley Clavette. Sorry, just want to be quick because I know that you guys are trying to wrap up here. While I think it's a great idea and very inspiring that we're considering other avenues for getting fuel in theater, I think that for me, a question that started to arise is that if we completely shift to JP5, there will come a time where commanders in theater are going to have to make the decision based on fuel rates of different assets, who's going to get the JP5 fuel. I'm a surface warfare officer. I don't think that the ship's going to get the fuel before the aircraft. Not my decision. I'm not really sure. So I was just wondering if in these scenarios and the computer systems based on the formulas that you would run, if any of them had considered for shifting one tanker to JP5 solely, single fuel, and another to DFM.
But this study is proposing precisely the opposite. Because by having a single fuel, that will extend the range for both aircraft and ships.
I can see that argument, what you're saying there, right? But if we're discussing retrofitting all of the ships, to be quite frank, we can't get out of the yards on time in the first place because of repairs that need to take place. That's just an existing issue. I don't want to linger on that, right? What I'm proposing is that if each tanker were designated to be a single fuel, instead of each tanker having two types of fuel, you said that tankers were going to be using just the one fuel of JP5. What I'm asking is if it was considered that one tanker solely carried JP5 and one tanker solely carried DFM when you use the diagram there of two tankers. Especially as we move into, we can discuss about retrofitting our ships and things like that, but the future as we look forward is more and more joint operations.
Yes.
Right.
So the Air Force and the Army have already done that.
Okay.
It's the Navy that is lagging behind on going to single fuel. I mean, there's probably somebody in the Army here that's going to correct me that I'm going to say something wrong, but I believe that the Army doesn't use gasoline anymore, for instance.
Okay.
That everything there, the same fuel that goes in the aircraft is the one that goes in the tanks. So single fuel, it extends the range for everybody. It's not sacrificing one at
So
the
are
back
you
on behalf of the other.
in the Army? Are you using JP5?
No, JP8.
Oh,
JP8, but JP8 cannot be used at sea because of the flash point being 100 Fahrenheit. So that's dangerous.
right.
We unfortunately cannot use the same fuel as done on land, but it's already being done. Everybody benefits. There is no question. There is no trade-off there.
Okay, we need to wrap up. So I'd like to thank our two panelists. Obviously hit a live wire, both of you, so thank you. Superb work. I appreciate your coming to moderate and give your presentation. Congratulations, Rebecca, on your impending joy. I wish you well. So thank you, everybody, for participating. A lot of good questions, and there's follow-on work. So please take Geraldo up on his offer to propose some thesis topics. There's quite a abundant student body at MPS who are eager to do work on things exactly like we're talking about. As you can tell from the questions of the audience, this is a near and dear topic for the warfighters, and it's an important topic, always has been. That's how you win wars, is logistics. So thank you very much, everybody.
Thank you very much, Admiral.
All right, take care. Bye-bye. Out here.